Okay, this time I'm going to do it in reverse order. I'm going to talk about the pattern recognition first, and then I'll do use substitution second. Okay, and again, you can choose to do these any way you like. I'm very, very partial to the pattern recognition, but that's okay. All right, now, so looking at the more complicated part here, definitely the x squared plus 2. Did the chain rule happen? Did I come from a fourth power? Right? And the chain rule happened. Well, if it did, this needed to not be x, but 2x. The derivative of the inside is 2x. So I'm going to place a 2 right there, and I'm going to make up for that by multiplying by 1/2. All right, now, so here's the thing. That and that will disappear on my antiderivative because they came out of nowhere when this derivative was taken. Now, so if that's true, then here's what I've got. I've got 1/2. All right, x squared plus 2 to my new exponent of 4 divided by the same plus c. Okay, so the answer should be 1/8 x squared plus 2 okay, I get a little lag, not too bad. Just be careful here. Plus c. Done. Okay, now, all right, let's try the u substitution. See what it looks like in this case when I had to make an adjustment. All right, and you may like this. Okay, so the inner part I'm going to call u. So u is x squared plus 2. All right, and the derivative with respect to x, and then multiplying by the dx gives me du equals 2x dx. All right, I got everything I need. Now, all right, so here we go. So we know that's going to be u cubed. That's fine. All right, but then I have an x and a dx that are left behind, right? So would it be best? I think it would be best to say that x is equal to, I mean, there's a couple different ways you could go about this, but I think the best way is to say x, and we'll substitute this x out. All right, so x would equal du divided by 2 dx. All right, and you're like, what's up with that? Well, what's going to happen is the dx is going to cancel. Okay, so there's a couple of ways we could have thought about that, but I kind of like that way. All right, so here we go. So x became du over 2 dx. All right, that's sweet. dx's are going to cancel, so I have a du over 2. Now I want to put that over here. So I've got a du over 2. The dx is canceled, and then we have a u cubed. Okay. All right, that's fine. All right, so what do you want to do? Well, I think I don't like the way that looks, so I'm going to take that 1/2 out in front and then do the antiderivative of u cubed du. Another way to think about that, and I'm not sure how Gene would show it, but is this. If I had x, now remember these are ones I added earlier. If I had an x dx, all right, that's fine, but I could say x dx would equal du over 2. So x dx, if you wanted to do that substitution instead, would be perfectly fine. We end up in the same place, du over 2. All right, I kind of like that because that way I don't have to think of the dx canceling. I just replaced it, right? So I just kind of had it tag along with the x, and this are the things that were sitting there. I isolated them, all right? So if I isolated the things that were sitting there that I circled, then it'd have a du over 2. All right, anyway, all right, it's all good. All right, so then here we go. So I got 1/2 u to the 4th power divided by the same. Looking familiar, right? Plus an unknown constant. All right, and so that gives me 1/8. But u happens to be x squared plus 2. Always make sure you go back because you want to answer in terms of x to the 4th power plus c. And there we go. Okay, now see, so that's a whole lot of work. It works though. I mean, it's got you a procedure here, and but right here we could think of either one of those and be in good shape. Right there. All right, but man, the pattern recognition was so much faster, so much faster.